Okay, so we're in week 4. Let's look at coordinate geometry. So first things first, we're going to look at equation of a line. So we know that an equation of the line is in the form y equals mx plus c. M is your gradient. So this tells you about your slope. So it's going to be positive or negative depending on whether you're sloping up or down. The higher the number, the steeper the slope. Plus c is your y-intercept. Now your y-intercept is when x is 0, what is y? So it's where you cross that vertical axis. There's a few equations that we need to know. Our gradient is our y2 minus y1 over x2 minus x1. You might have done it as rise over run, change in y over change in x. That's all this is, but in equation form. And an equation of a line, we learn a new way to write it. You can always substitute your gradient and your points in and find your plus c. But this just makes it easier. So in further maths, we find this easy way to find an equation of a line. Right, let's look at some questions. So we're given a straight line passes through some points. We want to work out the equation. Step 1, I'm going to find the gradient. So I'm going to say my m is, let's label these, x2, y2. So y2 minus y1 over x2 minus x1. So we get minus minus, so that's going to become a plus. So we've got minus 9 over 3, so we've got minus 3. Now I'm going to use that equation. Y minus y1, and I can use either of the points. Just going to use the first one. No reason why, actually it might have been easier to use the second one. So then my mx minus x1. You open that out, we get y minus 11 equals, now this is going to make a plus, minus 3x, minus 3 times 2, so minus 6. So y equals minus 3x minus 6 plus 11, so we end up with plus 5. So y equals minus 3x plus 5. Okay, next one. We've got points with a gradient again. We're looking at gradients. So x1, y1, x2, y2. We're going to get our gradient, which is going to be y2 minus y1 equals x2, which is a, minus x1, which in this case is minus 3. And we know that equals 12. So we get b plus 10 over a plus 3 equals 12. Okay, let's multiply this bit underneath up here. So we're going to get 12 times a to give us 12a, 12 times 3 to give us 36. And what we want to do is, I think it's quite easy to find an expression for b here. So we'll get 12a plus 26, and then we can just substitute values in. It says integer values, so we want whole numbers. So pick a number. I'm going to say if a is 1, it's probably the easiest one. B is going to be 12 times 1, 12 plus 26, which is 38. So here's an example. You could have chosen 0 and you'd have got 0 and 26 or anything like that. It's only 2 marks, even if they've left us a lot of space, but that's all we need to do there. Okay, so now we're going to look at a midpoint of a line or somewhere along the line, not necessarily the midpoint. If it was exactly the middle, if we have 2 coordinates, to find a point exactly in the middle of those, you add up the x's, you divide it by 2. You add up the y's, and you divide it by 2. And that would give you a coordinate of exactly halfway. Or you could say, how much have I moved up and down, and split that. And that's what we're going to be doing here. So we know that this is split in the ratio 5 to 2. Right, what we're going to do first is find our differences. So how do we go from 5, how do we go from 3 to 5? We're going across 2. And then if we want to go from 7 to 5.5, we're going down 1.5. So we're just looking at how much each bit of the space is. Now, this 2, if you like, is worth 5 bits, and we want to work out how much 2 bits are. So we're going to take that 2, divide by 5, and then times by 2, which will give us 4 over 5, which is 0.8. So now I know that across here, I've got 0.8. Now, for the 1.5, we're going to do exactly the same. Now, because I'm going to assume it's if it was in a non-calculator, dealing with fractions is a bit easier. So I want to divide by 5, and I want to times by 2. So that's going to give me 3 over 2 times by 1 over 5 times 2. And when I do that, I end up with, well, that cancels, and I end up with 3/5, so 0.6. So I know this bit is going to be changed by 0.6. So now I'm saying my 5, I'm going along an additional 0.8. So 5 plus 0.8 is going to give me 5.8. And 5.5, I'm going down by 0.6. So 5.5 minus 0.5 will take me to 5, minus that extra 0.1 is going to take me to 4.9. And that's me splitting that line up, just thinking about the ratios. Okay. Now we get to use our midpoint. So we get told M is actually the midpoint of the line AB. So we know this is our x1, y1, x2, y2. So I know if I add up minus 2 plus 7 and divide it by 2, I'm going to get P. And 3 plus R divided by 2 is going to give us minus 1. Okay, so from the first equation, we can see that minus 2 plus 7 is going to give us 2p. So 5 equals 2p, so p must be 5 over 2, or 2.5, depending on whether you like to write them as decimals. And then r is going to be 3 plus r equals minus 2. So then we're just going to say, well, r must therefore be minus 2, minus 3, so we get minus 5. Okay. The next topic is looking at the intercept of a line. So that's where something crosses an axis. So actually, let's have a look. There's lots of different types of intercepts. So if we take an equation, let me take a purple line here, and let's draw a blue line like that. Okay, so let's look at some coordinates. This here is where the purple line intercepts the y-axis. It's my y-intercept. So this would be 0, and it would be some y-coordinate. Sub-0, y1, let's say. And this as well would be a y-intercept. Here is where the blue line, so I know the purple line even, crosses the x-axis. And at that point there, that's an x-coordinate, and the y is 0. And where two lines meet, that's also called an intersection. So you've got to really think, like if they say, what is the intersect of the x? People normally immediately put x is 0. That's wrong. It's y is 0. So when you intercept the y-axis, x equals 0. And when you intercept the x-axis is when y equals 0. Okay, let's have a look at some questions. So we've got L is a straight line. At which point does it intersect the x-axis? So intersecting the x-axis means y equals 0. So when all of these y equals 0, but I'm going to make y equal to 0. So ax, b times 0 is just 0. So ax equals c. So therefore x must be c divided by a. So my answer would be here. Right. What is the gradient of a line parallel? Okay, when two things are parallel, their gradient is exactly the same. So if we have this, I can't see what the gradient is yet because I need it to be y equals mx plus c. So to find the gradient, I'm going to rearrange it to make y the subject of the formula. So I'm bringing the ax to the other side, becomes minus ax plus c. And now to divide by b. So putting everything over b, I can put each bit individually over b. And now hopefully you can see that this bit here is your gradient. If I compare it to the options, it's going to be that one there. Okay, now they've got to work out the point of intersection of the lines. Okay, so we've got simultaneous equations again, just in context. It's what we use them for. So we've got 2x plus 3y equals 11. I'm going to bring that 3x over, and we get 3x plus 2y equals 13. We want either the x's or the y's to be the same, so I'm going to make the x's the same. I'm going to times this one by 3 and this one by 2. So I'm going to get 6x plus 9y equals 33, and 6x plus 4y equals 26. So that's my 1 and my 2. That's my new 1, my new 2. I can take them away from each other. 9 minus 4 gives me 5y. That gives me 5y equals 7. So y is 7 over 5. I substitute it back in. So I might want to write that as 1.4. And I substitute it back in and get 3.4. If you want to go through this slowly, we've done it in the algebra section. There was the exact same intersection question when we were talking about simultaneous equations. Okay, now we've got equations of 3 lines. The lines intersect at the points O, A, and B, as shown in the sketch. Show that the length of OB, so let's find the length OB. So let's take OB, which is here, is equal to the length AB. So we're saying this yellow line is equal to that. Right, how are we going to go about doing that? We've been given the equations. We first need to identify, well, no, they've told us which one is which. Okay, so we need to identify some coordinates. If I want to find out the distance, the first thing I'm going to have to do is I'm going to have to work out the coordinate here and the coordinate here. Okay, so the coordinate of B is when 2x meets this graph here. So we've got 2y equals 11x minus 7 and y equals 2x. So this is easy because you've already got y equals something. You can just substitute the 2x, so the whole of the 2x can go into the y. So we get 2 lots of 2x equals 11x minus 7. 4x equals 11x minus 7. So we end up with 7x, 11 equals 7. So x is 1. Now if x is 1, y must be 2. So we know this coordinate here is 1. So 2 times 1 is 2. 1, 2. Okay, which makes sense. It's in the positive axes, so we're all good here. Right, now let's find A. A is when this line here, which is this, meets this line here, which is this. So let's solve those two simultaneously. So we're going to have 2y equals 11x minus 7 and x plus 3y equals 0. Okay, so again, a substitution might be easier because we can take this and just move that 3y. So x equals minus 3y. So we get 2y equals 11 lots of minus 3y minus 7. So 2y equals minus 33y minus 7. Add that onto that side. So we get 35y equals minus 7. So y equals minus 7 divided by 35, which is going to give you minus a fifth, which is minus 0.2. Then we can sub it back into here. Minus and minus make a plus, so plus 0.6. So this is going to become plus 0.6 minus 0.2. Right, so now we've got our points. We want to find the distance of OB. Left space there. So the distance of O to B and we're going to find the distance of A to B. Okay, O to B, let's think about this. That's our coordinate, is 1, 2. So all we're doing is the change in y, is drawing a triangle, because you're looking at how much different it is. So from 2 to 0 is 2 and 1. So O to B is going to be Pythagoras of 2 squared plus 1 squared. So I'm just going to leave it as square root 5. A to B is going to be your change in the x's squared minus the change in y. So let's think about a generalized difference between 2 points. It's always going to be x2 minus x1 squared, y2 minus y1 squared, and the whole thing square rooted. So in this case, we're going from A to B. So we've got 1 minus 0.6 squared plus 2 minus 0.2 squared. And then when we stick that into our calculator, this is calculator paper, we get root 5. And then we'll just say OB equals AB. So that shows how you find the length or the distance between 2 points. But it's mainly surrounding the intersection of them as well. Okay, parallel lines. We talked about this briefly when we came up with the question, but parallel lines are lines with the same gradient. So it's when the m are exactly the same. So y equals 7x plus 4 is parallel to 7x minus 3004. Doesn't matter what the plus c is. The bit we're concerned with is the gradient, which is the bit in front of the x. Okay, here we go, saying write an equation that is parallel to this. We've got a problem, we don't know what the m is because we need y equals. So we're going to divide both sides by 2. So we get y equals a half x. So we know the gradient will be a half. So we've got y equals a half x plus some c. We know when x is 4, y is 0. Don't be tempted to sub in c is 4 because it's the other way around. So let's substitute it in. So when x is 4, y is 0. A half times 4. So 4 divided by 2 is 2. So c must be minus 2. So my equation is y equals a half x minus 2. Actually, let's write that a bit neater. So we've got y equals a half x minus 2. Okay, so I hope that makes some sense. Right, now we've got a quadrilateral. What does that mean? So all a quadrilateral is essentially a four-sided shape. We're told that M is the midpoint of PS. Okay, well, we can find M. We know how to do that, don't we? We add the x coordinates, so 6 and 4, and we divide by 2. And we add the y coordinates, and we divide by 2. So when we do that, we get a P and S, yeah. So when we add the x coordinates, we've got 6 plus 4, which gives us 10 divided by 2 is 5. So that must be 5. 11 plus 1, which is 12, divided by 2, which is 6. So we've got 5, 6 as our midpoints. We want to use the gradients to show that MR is parallel to PQ. Okay, so we're going to find the gradient for each bit. Right, so let's do PQ first. So PQ. So for PQ, if I do x1, y1, x2, y2, and I'm going to take away. So we're going to do minus 3 minus 1 over 10 minus 4. Now, if you look at the slope, you're expecting a negative slope. I've got minus 4 over 6, which is minus 2 over 3. Okay, so that's the gradient of PQ. If I want, I could put an M here or even write gradient. And now I want a gradient of MR. So for M to R. So I'm looking for this one here. and I'm going to do exactly the same thing, right? And I'm trying to show that they're parallel. So I want to show my change in y over my change in x is exactly the same. So if I do 0 minus 6 over 14 minus 5, I've got minus 6, and then 14 take away 5 is 9. That also cancels down to minus 2 over 3. And so you're going to say MPQ equals MMR, therefore parallel. And you've shown your work and got your marks. And I think this question in total was, it's just 3 marks. Well, still, it was still 3 marks. Okay, next question. We've got a point on a circle and the equation of a circle. Okay, so what is the general equation for a circle? So your general equation for a circle is x squared plus y squared equals r squared. And that tells you that the center is 0, 0, and the radius is r. However, that center could shift. If it shifts, instead of x, it's x plus, remember x's do the wrong thing, so x plus 1 if it shifted to the left on the x coordinate, or if it shifted to the right. Okay. And every single point around the whole curve will satisfy that equation. Okay, let's show you what that means. So we've got an equation here. We've got x squared plus y squared equals 29. So that's saying the center is 0, 0, and the radius will be root 29. Okay, so that's what my equation is saying. And I want to show that P is on the circle. So I have my circle, I have my center, and I know this coordinate here is somewhere on the circle, which means it satisfies this equation. This is the x, this is the y. So I've got minus 5 squared plus 2 squared gives me 25 plus 4, which equals 29. So therefore I have shown that it satisfies that equation. It really is that straightforward. Okay, now what did we say? Sometimes the center shifts. And when it does, we have x minus a squared, y minus b squared equals r squared. And that's when the center isn't quite 0, 0. Right, so we've got a circle center C, and it touches the y-axis at the point 0, 2. And the line y equals k intersects the circle at 1k and 5k. And we've got to work out an equation of the line. So we need to work out how far in and out the line is. So what the center is and what the radius is. Okay, so if we're going to go from the center to the edge, we've got this line here, we can see that we're going from, this is 0 to some point here. How am I going to find that point? So if I have a look, I've got these 2 bits that cut it across. That's called cutting a chord. So if I draw a line up here, this gives me a radius as well. So does this. But if I go halfway, I'm going to cut this exactly in half. Okay. Right. Now remember, the general equation is going to be x minus a squared plus y minus b squared equals r squared. So all I know at the moment is that my center is in line with y equals 2, so I know the y coordinate of my center is 2. Okay, so that I can see really clearly. Right, I also can see my x coordinate, because if x is 1 here and x is 5 here, and this cuts it right in the middle, my x coordinate must be the middle of 1 and 5. So 1 plus 5 is 6, divided by 2 is 3. So So I get x minus 3 squared equals r squared. And remember, every point along the circle satisfies that equation. So I'm going to substitute this point in. So I'm going to get 0 minus 3 squared plus 2 minus 2 squared equals r squared. So you're going to get r squared equals 9. And so my final equation is going to be x minus 3 squared plus y minus 2 squared equals 9, which I could have seen because I know that the x goes all the way out. Right, let's have a look at the next equation. So we have two circles, each with a center 0 as shown. Okay. Work out the perimeter of the shaded section ABCD. Okay, so we've got a quarter of a circle that's been shaded. So let's have a look at what we're going to do with this. So first of all, we can use these equations to tell us the radius. So the radius of one of them is going to be the square root, because remember we've got x squared plus y squared equals r squared. So the square root of 289, so here the radius is 17, and here the radius, you hopefully recognise, is 11. So we know this space is 11, okay, and we know all of this is 17. Now the bit that's shaded is the big circle minus the small circle, okay? But in terms of perimeter, we're not looking for the area, we're looking for the perimeter. So we're looking for this bit, and then these two bits. So the easy bits are the two bits that we can find. So this is 6, and this is 6. This bit here is part of the circumference. So if you remember, the formula for circumference is 2 pi r. So if I say small circle is going to be 2 times pi times 11, but I've only got a quarter of it. So I'm going to divide that by 4. Okay? Right, and the large circle is going to be 2 times pi times 17 divided by 4. So when I add those up, work them out, so I get 2 times, it's a calculator, divided by 4 gives me, it doesn't say how many decimal places. Okay, so we can leave it as 5.5 pi, then 2 times pi times 17. So 17 times 2 divided by 4 gives us 8.5 pi. So we're going to get 8.5 plus 5.5, so 14 pi plus 12. Now, if it was a calculator paper and they may have asked for it in terms of decimal places, if this was the case, then you would just substitute in 3 significant figures. Here, because it's not clear, you could do any one that you liked. Okay. All right, so now we've got an equation of a circle, and this one's a little bit trickier. So if you have a look, you've got x's and y's, and they've all shifted. So it's not quite x squared plus y squared. What you're going to do is you're going to take your x squared section, and you're going to complete the square. And you're going to take your y squared minus 6y and complete the square for y. So half what's in front of the y, square it and take it away. Now we're going to put it all together. Equals 0. We can move the numbers onto the opposite side. And remember, x minus a squared plus y minus b squared equals r squared. AB is your center and r is your radius. So here we can see straight away that our center is 1, 3, and our radius is root 10. Okay, so now we're almost there. We're looking at the equation of a tangent to a circle. So those of you doing Edexcel GCSE, They've also, on the advanced information, explicitly said this is actually going to be in the GCSE specification as well. That should really be a straight line. I don't think I've drawn it very straight. Let's try again. So, okay, let's draw that as a tangent. So that's just meeting at one point. Okay, so from the center to a tangent, we know we get a right angle. So if this is my AB, and if we call, actually let's call this XY, the gradient from AB to your X1, Y1 is going to be perpendicular to the gradient of the tangent. Okay, let's work through an example, and that's going to make more sense. So we've got a circle. So we're given a circle here, and we're given a point. So let's draw the tangent here as well, because I know I'm going to need it. Okay, so we've got a circle, center 0, 0, because it's just x squared plus y squared. And there's a point here, which is -5, 2. We want to find the equation of the tangent to be able to find where it meets the axes. Okay, so step 1, we're going to find a gradient. So we're going to find the gradient of this line here to start with. So we've got our change in y over our change in x. So if we have a look here, we can say so it depends, like I said, we can use y1 and y2, we can do our rise over run, it doesn't really matter. So we've got our m, which will be -5 minus 0 over 2 minus 0, so -5 over 2. Okay. And we sense check, is it negative? Yes, we've done that right. Now the tangent is the inverse reciprocal, which means you flip it and you change the sign. So if that's the m of the radius to the point, the m of the tangent is 2/5. Now we know P is on that line. So we can use y minus y1 equals m x minus -5. Right, so we've got y minus 2, and this is where this equation comes useful. We don't need to rearrange it. We just want to find out where it intersects the x-axis. So it intersects the x-axis when y equals 0. So when y is 0, we get 0 minus 2 equals 2/5 x plus 5. So x plus 5 equals -2 times 5 divided by 2. So -5. -5. So x equals -10. So your x coordinate will be -10. Okay, let's have a look at the next one. So we've got another one. We've got a circle C as an equation, and P and Q are points on the circle. The tangent at Q is parallel to the x-axis. The tangent of P and Q are set. Okay, write down the coordinates of C. Okay, so that one's easy. So remember our equation, x minus a squared plus y minus b squared equals r squared. So if that's 1, our x coordinate is 1. This is plus 3, so our y coordinate is -3. Okay. Show that the equation of the tangent is y equals 2. Right, so we want to know from here to here, if the radius, so r squared, so if we know r squared equals 25, r must be 5. So if this is 1 minus 3, and this is 5, -3 plus 5 equals 2, therefore y equals 2. So we're going straight up by 2. Okay, nice. Work out the x coordinate of r. Okay, so we want to work out this coordinate here, which means we need to work out the equation of this line. To do that, we first need to know the equation of or the gradient of this line. So we want to know the gradient of the line from C to P. Okay, how are we going to do that? We do our y1 minus y2 minus y1 over x2 minus x1. So we want this equation here. So if we have a look from minus 3, so from minus 3 to minus 7, so if you think about that, that space is 4, and from 1 to 4, it's 3. So, and it's a negative line, so we've got minus 4/3. And we've got the 4 minus 7. Okay, so we've got 4 minus 7 as our thing, and our m of C to P is minus 4/3. So therefore, the gradient of the tangent is the inverse reciprocal. Remember, flip and change the sign. So 3/4. So we do y minus y1 equals m x minus x1. And we're trying to find out where that meets this line here, which we know is the line of y equals 2. So we substitute in, y is 2. So we get 2 plus 7 equals 3/4 x minus 3. So 2 plus 7 plus 3 gives us 12 equals 3/4 x. So x is going to be 16. The x coordinate is 16. Okay, that was a lot. Well done for those of you that have listened through. Hope it makes sense. Message, leave any comments with any questions you may have.